Hi everyone. So here is part 2 of your notes, and we are going to focus on angle relationships. The first angle relationship we're going to talk about is complementary angles. Complementary angles are two angles that add up to 90 degrees. So if we have two angles, let's go ahead and let's call this one angle 1. And let's say that there is another angle called angle 2. And if we were to add the measure of angle 1 and the measure of angle 2, their total would be 90 degrees. And this is what it means to be complementary angles. All right. We also have another relationship called supplementary angles. And this is similar to complementary. It's just slightly different. But basically, these are another two angles. But this time, they add up to 180 degrees instead of 90. So once more, I can have an angle right here. Let's go ahead and let's call this angle 3. Let me go ahead and get another angle over here. We can call this angle 4. And if you were to add these two measures together, measure angle 3 plus the measure of angle 4, they should equal to be 180 degrees. All right. The third angle relationship that we could have is called a linear pair. Now, notice how in the word linear, we have this word line again. So this is kind of what we're going to be looking for. A linear pair meaning two, so we have two angles next to each other that add up to 180 degrees. Now, you might ask and say, well, what's the difference between a linear pair and supplementary angles? Linear pairs are very specific in that your two angles have to be right next to each other. In other words, they're going to share a side. So this is what they'll look like. Let me go ahead and draw in a line. And let me draw a ray that comes out of that line. Let me go ahead and add some points. Point A, B, C, and D. Now, if we are taking a look at the two pictures here, the one for linear pair and the one for supplementary angles, notice how I have two angles. I have angle DBC and angle DBA. The side or ray BD is shared between these two angles. But angle 3 and angle 4 up here in supplementary angles, they do not share a side. They're actually two completely separate angles that do not connect with each other. So that's the key difference. But we can still write the same equation. And I'm going to use the names of the angles down here. So the measure of angle ABD plus the measure of angle DBC will be equal to 180 degrees. All right, last but not least, we have vertical angles. These angles are formed from two intersecting lines. These are two angles across from each other. All right, so let's go ahead and let's take a look at what this actually looks like in a picture. So let me go ahead and draw two intersecting lines. All right. And then now what I can do is I can choose two angles that are across from each other. Let's go ahead and let's name all four of these angles. I'll go ahead and name them with the numbers. So we had 1, 2, 3, 4. Let's call this angle 5, 6, 7, and 8. Now, angle 5 and angle 7 are directly across from each other. So angle 5 and angle 7 are vertical angles. And you'll notice that we actually have another pair, and that is angle 6 and angle 8. Now, one really important consequence of vertical angles is that they are congruent. So what this means is that angle 5 is congruent to angle 7. And because I have another pair of vertical angles, angle 6 is also congruent to angle 8. So what we'll do is we'll go ahead and we'll use all four of these relationships to help us solve for the measures of the angles in the next following examples. All right, so in this particular problem, it's asking us to name the relationship first between the two angles, and then we need to solve for the measure of angle ABC. All right, so in part A, it's asking us for the relationship between angle ABC and angle DBE. All right, so angle DBE has already been marked. It is right here, angle DBE, tracing it with my pencil. Angle DBE is 138 degrees. Now, angle ABC is this angle right over here. All right, and then if we remember our relationships from earlier, because these are two intersecting lines and angle ABC is across from angle DBE, this means that angle ABC and angle DBE are vertical angles. And because of that, we know that angle ABC is going to be congruent to angle DBE. So what this means is that their measures then are also equal, right? Because congruent means to have the same measure as well as the same type of figure. And because measure angle DBE is 138 degrees, right? Just by substituting in, this means that the measure of angle ABC must also be equal to 138 degrees. All right, taking a look at part B. Part B is asking us for the relationship between the angle ABD and angle ABC. So, same exact picture, but now we have two different angles to worry about. We have angle ABD, which is marked to be 57 degrees. And now I have angle ABC, which is this one here. All right. Now, thinking back again to our relationships from earlier, notice how angle ABD and angle ABC share a side. And not just that, but CD forms a straight line. So because they share a side and because they form a straight line, these are a linear pair. So angle ABD and angle ABC are a linear pair. Now, technically, you wouldn't be incorrect if you said that these were supplementary because that's technically what linear pairs, their measures will add up to. But it is technically more correct to say that they are a linear pair due to the fact that they share a side and form a straight line. Because keep in mind, supplementary angles do not need to share a side. Now, let's go ahead and let's figure out what the measure of angle ABC actually is. Now, because the measure of angle ABD added together with the measure of angle ABC is 180 degrees, we can now substitute and then solve for the measure of angle ABC. So substituting in, measure angle ABD is 57 degrees. And I'm going to go ahead and add the measure of angle ABC. Now I can go ahead and subtract 57 on both sides. These cancel out. And I'm left with the measure of angle ABC is going to be equal to 123 degrees. All right, let's go ahead and move into problem C. So problem C, this actually gives us already the relationship between the two angles. It says that the angle ABC and angle EDF are supplementary. Now, remembering from our notes earlier, supplementary means that the two angles add up to 180 degrees. So taking a look at angle ABC and angle EDF, we notice that angle EDF is 135 degrees. And if we need to solve for the angle measure of angle ABC, well, because these two angles add up to be 180 degrees, that allows us to write the equation. The measure of angle EDF plus the measure of angle ABC is equal to 180 degrees. Substituting in our known values or our given values, measure of angle EDF is 135 degrees, and I'm adding on the measure of angle ABC because this is what I'm solving for, and this is all equal to 180 degrees. I can now subtract 135 on both sides. The 135s on the left side cancel out, and I'm left with the measure of angle ABC is equal to 45 degrees. All right, moving into the last example, which is part D. Now, they're asking us for the relationship between angle DBA and angle ABC. Here is angle DBA, and we see that it's marked with 45 degrees. And here is angle ABC. This is the angle that we are trying to solve for. So let me go ahead and mark that. All right, now, there aren't any obvious clues in this particular picture as to what the relationship might be, but notice how there is a square mark on the inside of angle DBC. What this square tells us is that angle DBC, I'll write it up here, angle DBC is a right angle. So what this means is that angle DBC is equal to 90 degrees. And because I have ray BA separating the right angle, that means that angle DBA and angle ABC, when we add them together, they have to equal 90 degrees. And when we have two angles that add up together to equal 90 degrees, these angles then are called complementary. In other words, angle DBA and angle ABC are complementary. All right, now to finish solving for the measure of angle ABC, because angle ABC and angle DBA are complementary, this means that I can write an equation that says the measure of angle DBA plus the measure of angle ABC should equal to 90 degrees. Substituting in what we know, the measure of angle DBA is 45 degrees. Adding the measure of angle ABC should equal 90 degrees. I can now go ahead and subtract 45 on both sides. This cancels out my 45 on the left side, and I am left with the measure of angle ABC is equal to 45 degrees. All right, that's all for today. Thank you so much for watching.